Alright gang, I'm redoing this video. The last one took 12 minutes and this shouldn't take that long. So let's get through this. This is a time saver. Descartes' rule of signs. The only point to Descartes' rule of signs is that it's going to help you narrow down how many zeros there are based on your lists that you create with the rational zero test. If you remember the rational zero test, you list all the factors of the last term over all the factors of the first term. It could be positive or negative. You could end up with a really long list. And so what this rule of signs is supposed to do is supposed to help you narrow that down so that once you know you have a certain number of positive answers, you know that you don't have to try for any more. And this is what it says. All right, the first part says the number of sign changes on f of x is equal to the number of positive real zeros or less by an even integer. The number of sign changes on f of x is equal to the number of positive real zeros or less by an even integer. And the second part of this rule is pretty easy as well. The number of sign changes on f of negative x is equal to the number of negative real zeros or less by an even integer. The number of sign changes on f of negative x is equal to the number of negative real solutions or less by an even integer. Well, that's terrific. Can I get that in English now? Yes, you can. This is basically what it is saying. Let's talk about the first part, sign changes. Let's talk about the first part to the first part, okay? Because we're talking about the number of positive reals. So let's say we have f of x equals negative 6x to the fourth plus 3x to the third plus x squared minus x plus 2. Okay, when we talk about the number of sign changes, we're just talking about the signs on the coefficients. We have a negative, positive, positive, negative, positive. The number of sign changes, we have 1 here because it goes from negative to positive. We have 1 here because it goes from positive to negative. We have 1 here because it goes from negative to positive. So there are 3 sign changes. And what that means is that there could be 3 positive real zeros. So we've already taken 2/3 of this statement apart. We talked about the sign changes and the number of positive real zeros. This last little bit, or less by an even integer. An even integer, integers are just the counting numbers. The even ones are 2, 4, 6, and so on. All right? So basically we're going to take this and every number that's less than it by an even integer. 3 minus 2 is 1. 3 minus 4 is negative 1. 3 minus 6 is negative 3. Stupid negatives aren't showing up. All right, well now these negatives don't make any sense. You can't have a negative number of answers. But you can have 3 or 1. There are 3 or 1 positive real solution. All right? Okay, let's take the second part of the statement. The number of sign changes on f of negative x is equal to the number of negative real zeros, blah, blah, blah. All right, let's use the same exact function that I just had a second ago. It was f of x equals negative 6x to the fourth plus 3x cubed plus x squared minus x plus 2. Let's see if my Apple Pen works now. Yeah. Outstanding. Now I can actually write legibly. All right. So if that's what f of x is, then f of negative x, well, that means you're going to plug a negative x in to each of these x's. And it should be fairly obvious to you that if you take a negative and you raise it to an even power, it does not change. It turns positive. So what that means is that this will not change, this will not change, and obviously this will not change. It's the odd powers of x that are going to change when I plug in negative x. All right, so that means my function is going to be negative 6x to the fourth minus 3x to the third minus x squared plus x plus 2. So everything is the same except for the 2 that I circled, the odd powers of x. And now I go through the same process that I did in the last example, find out the number of sign changes. There is 1 right there. 1 sign change. So that means that I will have, and remember the less by an even integer, well, if I take 1 minus 2, I have negatives. So that means I'm guaranteed to have one negative real solution. So you can see that it's helpful because it narrows things down. Once I find that one negative real solution, I don't have to try any more negatives. All right, let's put it in action. Number of sign changes on this original function. I have 1. I have 1, 2, 3. 3 or 1 positive real solution. It took me 5 seconds to figure that out. F of negative x, it's going to change this and this. 2x cubed plus 5x squared plus x plus 8. There are no sign changes. Great, because that means there will be no negative real solutions. All right, then you go through and you find your zeros using all the tricks that we've learned so far, but this is gonna limit the number that you have to look for. All right, last example. Number of sign changes, I have 1, 2. I have 2 sign changes. Less by an even integer would be 0. I have 2 or 0 positive real solutions. F of negative x, and you don't have to write it out. You can just realize that this will stay positive, this will change to positive, this will stay negative, this will change to negative, and this will stay positive. You don't have to go through and actually write out the whole thing, but I will. All right, so what do we got? We have 1, 2, 2 or 0 negative real solutions. All right, that is the end of the video. Did I shorten it?